Hello, good morning class. So welcome back to the physics class. You have been doing the chapter number 4 since last two classes. Chapter number 4, reflection of light at a plane surface, and we have completed till this topic called speed of light in our last class, isn't it? And we saw the speed of light. Okay, light travels in a straight line, important thing to be remembered, and it travels with the speed of 3 into 10 to the power 3 into 10 to the power 8 meter per second, where in vacuum or air. Alright, so today we will be discussing about the spectral light and colors. So we will be mostly dealing with the colors which are present in the light. Now what is this word called spectrum? Now you have seen rainbow. You have seen a rainbow. Rainbow has 7 colors, isn't it? Starting from V, I, B, G, Y, O, R. So this is the word by which you can remember the colors which are present in the rainbow. V stands for violet, I stands for indigo, B stands for blue, G stands for green, Y stands for yellow, O stands for orange, and R stands for red. So these are the 7 colors which are present in the light. So actually the rainbow that which you see after the rainfall is actually because of the refraction of light, which you will learn in the higher classes. When you reach class 10, you will be learning about the refraction of light. Okay, right now you have just learned about the reflection of light. So you see that light, actually the light coming from the sun actually has this 7 colors. Okay, so when you see all these 7 colors together, you see it as white. Understand? But when these 7 colors do not reach you, the surface or the things look what? Black. So basically white and black or black and white are not colors. They are not colors. Actually they are not the colors. Presence of all 7 colors makes white. Absence of all 7 colors makes black. So that is why you have heard about black and white photographs, black and white television, isn't it? So black and white actually means no color. Understand? There is no color. Presence of no color makes white and black. So black and white are actually no color in our sense of physics. Understand? So in the spectrum of light emitted by its source, we get different colors. So here from the source of light, here the source of light here is sun. So from the sun we get these 7 different colors. For each color the wavelength is different. So about wavelength we'll learn in the higher classes. Understand? In fact, wavelength is the characteristics of irrespective of its origin. That is, the light of same color obtained from different sources will have same wavelength. So just remember this much. Okay, so violet, if it has a wavelength of A, so this violet color is coming from sun. But if there is another violet color which is coming from some electric bulb, then also it will have the same wavelength, that is A. Understand? So wavelength of a light, okay, or wavelength of a color does not depend on the source. Whatever may be the source, a violet light will have always same wavelength. Understand? Okay. Now let's go to the next topic, that is primary colors or additive primaries. A color which cannot be obtained by mixing other color, okay, is said to be primary color. So those colors which cannot be obtained by mixing any other colors, okay, they are called as primary colors. So how many primary colors are there? There are 3. Okay, what are they? They are RGB. What we call them? RGB, red, green, blue. So here you can underline red, green and blue are primary colors because they can be combined to obtain all other colors. So why do we call them primary colors? Because you can combine them in some fixed proportion to get any other colors. यो 3टा कलर चाहिँ मिक्स गर्यो भने, okay, you can get any other colors which are present. So that's why they are called as primary colors, and these colors cannot be obtained by combining all other colors. This is the what second reason for calling these three colors as primary colors. All three colors combine to give white color. So you see red, green, blue mix gare भने चाहिँ what do you get? You get white. Understand? So experiments on mixing colored light, however, show that yellow can be obtained by mixing red and green. Also, green color cannot be obtained by mixing light of colors, other colors. Hence, red, blue, green are called primary colors. Understand? Now, what are secondary colors? Or secondary colors are also called as subtractive. Yeah, additive bande थियो, जोड्दै थियो नि हैन, you were adding them, mixing them, and that's why you are getting the other colors. Now, what are secondary colors? The secondary colors, the colors of light which are obtained by mixing two primary colors are secondary colors. They are yellow, cyan, and magenta. So, yellow, cyan, and magenta. Okay, so if you all have printer at home, okay, with the tank, you can see there also written YCM. So they are what colors? Secondary colors. Now why do we call them secondary colors? Because you can mix them to get other colors. See, yellow is made by mixing red and green color. Cyan is made by mixing green and blue color. Magenta is made by mixing red and blue colors. So yellow, cyan, and magenta are actually made by using the primary colors like green and blue. But what you are getting? Cyan. Red and blue, but you are getting magenta. Similarly, you are getting yellow by mixing red and green. So remember, I may give you in the exams. Okay, green plus blue equals to dash. So you have to write cyan. Understand? So you have to learn these paragraphs properly. So mark this paragraph and learn it. Understand? Now comes your color triangle of addition. So this is your color triangle of addition. Okay, so we call it as color triangle because here we can get any other shade of colors. So a color triangle is a triangle formed by the lines joining the primary colors, which represents the boundary, okay, a range of colors that can be matched using these three primary colors inside the triangular area can be matched exactly, while those outside of the triangle can be matched only by adding a negative contribution from one of the primaries. So primary colors red, green, blue are located at the vertices of the equilateral triangle. So we have equilateral triangle here. So here vertices, this is your red, this is your blue, this is your green. So when you mix green, red and blue, what do you get? You get white. Understand? When you mix red and yellow, green, you get yellow. When you mix blue and green, what do you get? You get cyan. When you mix blue and red, what do you get? You get magenta. So they are all what? Mixed in this way. You can mix and you can obtain any other colors. So the order of the color is such that sum of any two additive primaries at the corner gives the secondary color between them, isn't it? यो कुनाको र यो कुनाको mix गर्यो भने यहाँ बीचमा के पायो? Secondary color. So primary colors, two primary colors are mixed to get the secondary color. So this is what we call color triangle. Understand? Now comes colors of objects. The color of the body depends upon the color of the light which it absorb, reflect, and transmit. So you see around you, trees are green in color, isn't it? You can see many different flowers which have different colors, isn't it? You can see so many things in and around you which have different colors. So how are those colors formed actually? How are you able to see? Okay, so all the colors of light, colors of the objects and the things that you see around yourself or around us is actually the light which is getting reflected. Okay, so moreover, it depends on the color of light falling on the body. So please remember here, put a star mark here. So different colors of light is actually because of the colors of light falling on them. Pure green body reflects green light and absorbs the light of all other colors. So here you see, you are able to see this yellow because this part of this color triangle okay, or this one, this is blue, isn't it? Here this is white. So what happens? Why do we see white? Because this surface reflects all the 7 colors, and all 7 colors reaches your eye, and when all the 7 color reaches your eye, you see the thing as white. Whereas the pen with which I'm writing here is making which color here? Black. So why I am able to see black here? Because this substance or this part of this screen is able to absorb all 7 colors of light and reflects none. कुनै पनि light reflect गर्दैन, त्यो भएर चाहिँ यो के भएको? कालो भएको. So it depends. So here you can see this as blue because this part of the screen is able to absorb all other colors except blue. यसले blue लाई मात्र के गर्दिन्छ? Reflect गर्दिन्छ. So that blue light now goes to our eye and we see the things as blue. So understand? So it will appear green in any kind of light containing a green component, but black in any other light. So remember, okay, remember this part. Now for example, make a drawing on white paper with red crayons. You can do this activity at home. Okay, drawing on a white paper with a red crayon and others with green. When red light is allowed to fall on white paper, red part will be reflected only red color, whereas the green part will reflect appear black because it cannot reflect the red light. So के भन्नु खोजेको भन्दाखेरि चाहिँ you can see here this experiment here. So here what is happening? One experiment is being conducted here. White light falls, so that's why you see this red rose. But if this rose reflects all the white light, this rose will look what? White. Understand? And if it does not reflect any light, it appears to be black. Understand? So if you see the drawing in the green light, red part will appear black and green part will appear green only. So what is actually we are trying to say here is that if you have, okay, I make a flower here. So you see that this flower is blue in color. So I have a flower which is blue in color. Now I make its leaves here. Okay, the color of the leaf is green here, isn't it? So now if I allow the white light to fall on it, so I'm allowing which light? White light to fall on it. So when the white light, when the white light falls on it, this flower will absorb all other colors of light except blue. That's why I will be able to see it as a blue color. Similarly, this green leaves will absorb all other colors except green. So only green will be reflected from the leaves. So I am able to see the green leaf and the blue flower. But now if I allow the blue light to fall on it, I will be able to see only the color of the flower, that is blue. Whereas this green leaf will absorb the blue light and reflect none. So when it reflects none, it will look black. So what I'm trying to say is that the color of an object actually color is not present in the object. Okay, color is actually because of the reflection of light. Which color light is being reflected? So here you see that this green leaf was not able to reflect any light. It was it was absorbing the blue light. That's why it was reflecting none. So when it reflects none, the green leaf will appear to be as black. So what I'm trying to say here is that the color of an object actually depends on the reflection of light, or you can say what color of light it is being reflected. Understand? So you might have noticed that red color bulb is used in test cricket matches so that it reflects red light during daytime and is easily visible to the players. But for night matches, white color bulb is used in yellow light in the stadium so that it reflects yellow color to become visible. So that is the logic behind using the red color ball in the cricket in the daytime and white color ball, okay, in the night. Understand? So if red color ball is used instead of white ball during the night matches, then it won't be possible to play the match as the ball will appear black. And when it goes up, what happens in the night, the sky appears to be black and you will not be able to see the ball. Understand? So this is the logic behind using the red and white balls in the cricket during the day and night. Understand? Now, color of an object is in artificial light. Okay, objects often appear to have a color different from their natural color when viewed in artificial light. Now, what does this mean? See, in the daytime, in the sun, the clothes that you are wearing will appear to be of different color in the night when you are seeing or when you are viewing in the light, electric light, isn't it? घामको उज्यालो र बेलुकाको यो बल्बको उज्यालोमा the colors of the clothes will look different. Okay, this can be noticed in the light from the mercury vapor lamp or sodium vapor lamp now used to light roads and stadiums. Light from mercury vapor lamp have very strong yellow, green and blue components, while from the sodium lamp it is strongly yellow. Okay, so the source of light also changes the color of an object. Understand? Now, colors of transparent substances. A colored transparent substance usually reflects light of certain colors, absorbs light of other colors and transmits certain colors. Hence, a piece of glass might reflect red light, absorb orange, yellow, green and violet and transmit blue. Okay, so thus the apparent color of the glass depends on whether the eye receives light which has passed through it or light reflected from it. Okay, so what happens when nothing reaches your eye? The object looks transparent. Now, colors of opaque substances. When light falls on an opaque substance. Opaque means the substances which does not allow the light to pass through them. It reflects few colors and absorbs the rest. A red flower appears red in the white light. See here, white light, because it reflects red color and absorbs all other color. Okay, from the 7 colors it absorbs, this red flower absorbs all other colors except red. Red mother reflect गर्छ. That's why the rose appears to be red. Whereas on the other hand, a white flower reflects all colors and absorbs none, hence it appears to be white. So this white rose is appearing white. Why? Because when white light falls on it, it reflects all the colors without observing any. So that's why it reaches to us. All the color reaches to our eye, that is white light. Okay, all 7 colors together is called white light. Okay, so the flower, the rose, appears to be white. Okay, moreover, a flower which appears red in the white light appears bright red in the red light and black in any other color, as it reflects only red light and absorbs all other colors. So if you have a red flower, okay, in presence of red light, the red flower will appear very bright red. But if a red flower is placed in a light which has other colors, it will appear to be black because it absorbs all other colors except red. So red flower like blue light ma rakhe bhane kasto dekhcha? Black dekhcha. Why? Because that red flower has the property or ability to absorb the blue color. Understand? So this has to be understood. So any object which reflects none of the color appears black because it absorbs all colors. For example, a black black shoe appears black, okay, because it does not reflect, okay, any other color and absorbs all the colors. So as I said you, okay, as I said you, the reflection is actually the reason behind the colors of different objects. So if I have a blue ball, okay, I have a blue ball. If I keep this blue ball in a blue light ma राख्यो भने चाहिँ this blue ball will appear to be very very bright blue, एकदमै चकिलो blue भएर देख्छ. blue dekha. Understand? But if you place this blue ball in the yellow light, what will happen? This blue ball will absorb the yellow light and it does not reflect any light. It reflected गर्दैन भने के देख्छ? Black. Understand? So a black substance is black. Why? Because it absorbs all the light falling on it and reflects none. Whereas a white object appears to be white because it reflects all the light and absorbs none. भनेको चाहिँ, what I'm trying to say is that when an object absorbs no light, it appears to be white. Understand? When the object absorbs all the light and reflects none, the object appears to be black. Understand? So I hope you have understood this. If you have any confusion, you can ask me in the class group. Alright, so that's all for today. Thank you.